Hi, welcome to Code. In this video, we'll be looking at stacks. So this video is part of a series called Data Structures, and we already have covered linked list in that. So if you haven't watched that yet, go check them out. So now in this video, we'll be looking at stacks, and first we'll see what stack is, and we'll try to code it later that. In this video, we'll particularly be covering the stack implementation with arrays. The next video that will come out after this video in this series will be stack using linked list, which is very similar to this video, so check that when it comes out. When you hear the word stack, or when I hear the word stack, a couple of things comes to my mind. So the first one is Stack Overflow, obviously, the great god of all programmers, and the second one is a stack of books. Okay, so when we come to the stack of books, that is exactly how a stack data structure behaves. Okay, so if you imagine a stack of books, and if you want to place a book into it, what will you do? We have a stack of books here, and we want to insert a book into it. We cannot do it in the middle, right? We'll always do it at the top of the stack, or the top of the stack of these books. We'll do at the top. And when we want to remove a book from the stack, we'll also do remove from the top of the stack. That is what we do, right? If we want to remove it from the middle, that we usually don't do. If we want to do that, we'll take the books above that, have it as a separate stack, remove this particular book, and combine the stack again. That is how we do, right? If we try to remove a random book from the middle, the whole stack will collapse, and that we don't want. So generally in a stack, the insertion or deletion is performed only at the top. Okay, so this is something that I wanted you to know. When it comes to a stack, the insertion and deletion happens at the same side. Okay, this is something that you have to remember when trying to code or do anything that is regarding with stack. Okay, so this stack data structure has many applications. You will be using it quite a lot. So you have the very simple application can be like reversing a number or reversing a string. Okay, so when we have a string is generally just a collection of characters, right? Like in a language like C, we'll say string itself is a character array, but string is just a collection of characters. So if we want to reverse a string, what we can do is we can use a stack. Okay, so we know that we insert at the top, we also remove at the top. So this gives a unique property to stack, and what we call that is last in first out, LIFO. So this is something that you will hear always when it comes to stack. Okay, last in first out. So what it means is, if we have a set of numbers, we are inserting 1, 2, 3, 4 and 5. If I'm going to insert 6, it will be at the top of the list, at the top of the stack. If I want to remove a number, I can only remove 6, right? And 6 was the number that came at last to the stack. 6 was the number that came at last, and that is the one going out first. So last in, first out. So this is the principle of stack, or this is how stack works. So we have a couple of things to note. Stack uses the principle last in, first out, and the insertion and deletion both happens at the same end or at the top. So these are the two things that you need to remember when it comes to stack, and like both these things are almost telling you the same thing. Okay, so now when you see how to reverse a string, let these characters be 1, 2, 3, 4 and 5. Okay, so I know these are numbers, but for this example's sake, we'll have them as characters. So when we insert these numbers into the stack, it will be in the order 1, 2, 3, 4 and 5. And when you try popping elements out of the stack, so there are two words called push and pop for stack. So push is when you insert an element into the stack, and pop is when you take an element out of the stack. Both push and pop happens at the same end, at the top. Okay, so when you push elements from 1 through 5, first we'll have 1, that will be the top element, and then we'll insert 2. Now 2 will be the top element, and subsequently we'll be inserting numbers from 3 to 5. Okay, now we have a stack of numbers from 1 through 5. So the bottommost element will be 1 and the topmost element will be 5. Now 5 was the element that was inserted at last, and when we try to pop elements out of the stack, that will be the first element that comes out, right? 5 will be the first element, and after that 4 will be the second element, and so that is the order it comes out of the stack. When we try to pop elements from the stack, it will be in the reverse order of the order that we inserted elements into the stack. So like last in first out, right? So the element that was inserted at last will be popped out first. So when we insert these numbers 1 through 5, and when we pop these numbers from the stack, we'll be returned with 5, 4, 3, 2, 1, and that is this basic example or basic application of a stack. You can use a stack to reverse strings, to reverse a number, or anything in general. When we want to reverse something, you can use a stack, because the last element that goes in will be the first element to come out, and that can be used to reverse anything. Okay, so that is that. So there are so many other examples or applications of stack, like infix to prefix, postfix evaluation, and so many other things, and we'll not be going into them right now. But what we'll see right now is implementing this stack using an array, and we are going to do that in Java, specifically in IntelliJ. So now here I have a class called stack array. Okay, you can just have it as stack, anything is fine. Now what we'll be doing is, let me just bring my laptop. So what we'll be doing is, we are going to implement this stack with an array, right? So we'll first declare this array. You can have any element as the element of stack. You can have integers, character strings, anything, but for simplicity we'll have integers as the element. And let me just name the array as arr equals new int of 5. So I'm just declaring an array of size 5. So the maximum number of elements that the stack can store will also be 5, because we are using this array to implement stack, right? So it will also be 5. You can have a very huge number, but I am giving 5 because we have to handle the case where the array is full or it is empty, right? So for it to be handled easily, I need a number that is small, so that the inputs can be easier. So that is why I am giving 5. But if you are implementing it for an application, give a very large number. Okay, so we have created an array, it is of size 5. Okay, now what we'll do is, we'll have a variable, integer variable called top, and it will be initialized to 0. So this top variable will denote the top of the stack. Okay, so it is saying that top equals 0. So it just means that top will be the index where you can insert elements into. So initially we have top as 0. It just means that you can, when you try to insert an element, it will be inserted at the 0th index of the array. For every insertion, you will be incrementing the value of top. That we'll see in the push function. Okay, for now we have created a variable called top, and we have initialized it to 0. Now we need a couple of functions. We need 3 functions to be precise, but first we'll start with the push function. As I already told, push is the method or the name that we use for inserting elements into a stack. So first I'll write the push function. Okay, so this push function doesn't have to return anything, so we'll just have void as its return type, and push as its name. Although it doesn't have to return anything, it does have to get an argument, because we need to insert an element into the stack, right? So we need to know which element we are going to insert into the stack. So that we are getting as an argument, int data. So data is received as argument, and we are going to insert that into the stack. Now before inserting it into the stack, we need to check if the stack is already full. If the stack is already full, we will be printing stack overflow. So this is the place where the name stack overflow came from, right? So if we have the stack and the stack memory is completely full, the error that we give there is called stack overflow. You might have received this error when trying with recursions, or some other example where you are trying where you are trying to use a stack, or the compiler itself uses stack internally. So whenever the stack size is full and you try to insert elements into it, that is when you get the stack overflow error, and that is what we are going to do right now. So we are going to check if the stack is already full. If it is already full, we are just going to print stack overflow and we'll just abort the function. Okay, so that is what we are going to do right now. And how exactly do we check that is, we have the if condition and we see if top equals 5. Okay, let me just explain this. Top is initially at 0. Okay, we are using an array which uses 0 based indexing. So we can insert values from index 0 to index 4. Okay, 0, 1, 2, 3 and 4. So we have 5 values. It starts from 0, goes up to 4. So if the value of top is 5, it just means that we have elements from 0 to 4, and if you want to insert a new element, it should be at place 5. But we exactly know that that is not possible because the size of the array that we have declared is just 5. So it will definitely produce out of bounds index error. So we, instead of producing that error, or instead of letting that occur, we are just going to say stack overflow system.out.println stack overflow. Okay, and just return. So if top equals 5, it just means that the array is already full and we are just returning stack overflow. I mean, we are just printing stack overflow and returning the function. Okay, so in this case I have given 5, but in general you can give array.length. So that will be more appropriate because the size of the array may be anything, right? Okay, so we have handled this edge case. If the stack is full, we cannot insert further into it. Now, else, if the stack is not empty, what we'll do is we'll just insert ARR of top equals data. Like as I already told, top will be the value or the index at which you can insert your new data into. Initially it will be 0 because no element is present in the array or the stack, so you can insert element at the 0th index, so top is 0, and that is what we are using here. We are inserting at the top's position or the index at top. Okay, so array of top equals data, and after doing that we are incrementing the value of top because the current value of top has already been occupied by the data that we received right now, right? So we are incrementing the value of top. So that is it. So this function will insert values into the stack and will return the stack overflow error if the stack is full. Okay, now to check if this function works fine or the whole of stack works fine, we need to have a print function, right? So void print, I'm just going to have a print function, and this is going to print all the numbers in this array or the stack. So since it is a stack, we have to start from the top and go to the bottom. So I'm going to have a for loop and it is going to print elements in the array in reverse order. So int I equals top minus 1. Okay, I greater than equals 0, I minus minus. So we are giving top minus 1 because top is the value where we don't have any element, and that is where we can insert new elements. So the last element will be at top minus 1. So we are starting from top minus 1 and we are going all the way up to 0th index in the decreasing order, and we are just going to print the values in this indexes. Okay, ARR of I. Okay, now this print function will be printing all the values in the stack. Now before that I'll just give a print statement called printing values in a stack. Printing values in a stack. Okay, now this print function will print values, all the values that are present in the stack. Okay, now we'll see if this push function works fine and we'll move on to the next function. So to see if the push function is working fine, I have another class called stack controller and we have a main function inside that. Now what I'm going to do is I'm just going to create an object for this stack array class that we just wrote. Okay, and I'm going to name the object as stack equals new stack array. Okay, so I've created an object for this. Now with this object you can insert values into this, or you can call the push function to be more specific. So stack dot push of 12. So 12 will be the data that is going to be inserted, and the second value that you want to insert is like maybe it be 34. Okay, now we'll see if it is working fine. Stack dot print. So this should be printing 34 and then 12. Okay, now I'm just going to run this and we'll see if it is working fine. So printing values in the stack 34 and 12. So the push function is working fine and the print function is also working fine apparently. Okay, now we'll come to the second function in the stack, that is pop function. So generally this pop function is going to remove elements from the stack, or to be specific, remove elements at the top of the stack. And conventionally we have this stack with this pop function will also return the value at the top of the stack. Okay, so that is why we are going to have integer return type. So this pop function not only removes the element at the top, will also return the element. Okay, and we don't need to get any arguments for that because we are just going to remove the element at the top. Okay, now before removing elements we have to check if the stack is not empty. If the stack is already empty, you are not going to you cannot remove elements from the stack, right? So we are going to check if the stack is not empty. So how do we do that? Again, we are going to use the top variable. We are just going to check if top is less than or equal to 0. If the top is less than or equal to 0, it just means that the stack is empty, because initially, as we told, top will be 0, right? Top will always denote the index at which we can insert new values into. If it is 0, it means that there are no elements present in the stack, and that is what we are going to do. And this error is called stack underflow. Like, so creative, right? Who could have guessed it? Stack underflow. Okay, so that is the error that we are going to give, and since it is an integer function, we have to return something, right? So I'm just going to return negative 999, just a random value. Okay, so we have checked the edge case, that is the stack underflow error. To be more precise, if the stack is already empty, we cannot remove elements from it. That is why we are going to print this error and return some random value. Now if this is not true, it just means that we can remove elements from the stack, and we are just going to remove the element. So how do we do that? Before removing this element, we have to return that as well, right? So what we'll do is we'll just take a copy. There are so many ways of doing this, I know. There are simpler ways, like you can just return ARR of top minus minus, but for simplicity or for easy understanding, I'm just going to copy the variable. So what I'm going to do is int temp equals ARR of top minus 1. Okay, so why am I using top minus 1? Because top will always, I'm just repeating myself again, top will always be the value at which you can insert new elements into. So we are going to return top minus 1 because that is the last value or the top of the stack value. Okay, so I'm taking a copy of the top value and I'm just going to decrement the value of top. Okay, what exactly are we doing here? So I'm not going to erase the value that is present in the array. I mean the stack or the array, because we have implemented that using the array, right? So I'm not going to erase the value. Instead, I'm just going to tell the program that you can insert new elements into this array or this particular index. So that is what we are doing by decrementing the value of top. So for example, if you are at the second index, okay, you are at the second index. So when top is at the second index, it means that elements can be inserted at top, right? Okay, now if I want to delete an element, it will be the element at the first index, because top is at second index, so the element that is going to be deleted will be at the first index. So if I want to delete it, I am just going to decrement the value of top. It means that top will be pointing the first index. Okay, we are not deleting anything, I am just changing the value of top so that it points to the first index. So when we are going to insert a new element, that element or the new data that we are going to insert will override the existing value. That is the logic of it. So we don't have to make it 0 or anything like that. So I'm just decrementing the value of top, and we are going to return temp, because as I already told, the pop function conventionally returns the top of the value as well. So that is it. Now we'll try to call this pop function and see if it is working fine. Now after this print function, I am going to call the pop function. Okay, now we have inserted values 12 and 13, and the print function will be printing 12 and 34. The print function will be printing 34 12 because it is a stack, so it will be printing in the reverse order. And when we call the pop function, the 34 value will be removed, or it should be removed, because that will be at the top right. And to verify that, we'll again try to call the print function, and now we'll try to run this. Okay, so 12 is the only value that is currently present in the stack. It just means that 34 has got removed and the pop function is working fine. Now we have another feature for this pop function, right? It will be returning the element that is going to be popped. So I'm just going to have the print statement and call the pop function inside that. So the element that is being returned, or the top element, will be printed also. Okay, so we have the 34 printed, so it means that 34 is the element that has been removed from the stack. Okay, so the pop function is also working fine. Now we have one more function called the top function. Like, what a surprise, the top function will just return the top element of the stack. Okay, so it is very simple. You can do it by yourself, but I'm just going to do it anyways. So the return type will obviously be int, because it is going to return the top value, and it is not a big deal. You don't have to get any arguments for that. Just return ARR of top -1. Remember, top -1, not top, because top will be, like, again repeating myself, but top will be the index at which you are going to insert new elements. So top -1 will be the top, and the top -1 will be the top element. So we are just going to return top -1, and we'll just check this as well. Okay, system.out.println stack.top. okay, stack.top. So now as we already saw, we are inserting the numbers 12 and 34 into it. We have already popped once, so 34 will be popped, right? And now we are asking the value for top. So the top value will be 12. I'm just going to have a print statement like top, because we have so many lines of print statements, so we cannot identify them correctly. So I'm running this, and obviously, as expected, we have the top value as 12, and it is right. We are inserting values 12 and 13 into it, and when we print the stack, it will be 34 and 12. And here we have the pop function, and we have that inside a print function, so it will be printing the top value. So 34 has been printed, and right after that we have called the top function. So the top function has printed the top value, that is 12, and after that the remaining stack is just 12. Okay, now we have checked all this. Now what we have to do is we have to check if our error handling is working fine. So I'm just going to erase all this and call the pop function. So I just created the stack object, so there is no element present in the stack right now. So when I try to call this pop function, it should print stack overflow error. Stack underflow error, because there is no element present in the stack, and I'm going to try to pop an element out of it. So it should be stack underflow error. We'll see if it is working fine. And stack underflow error, and the print function says there are no elements in the stack. Okay, so the stack underflow error is working fine. Now we'll see if the stack overflow error is working fine. So this is the reason I gave the value as 5, right? Because I'm going to insert 5 values into it. int I equals 0, I less than 5, I plus plus. Okay, we have a for loop that runs for 5 times, and I'm just going to push the values of I that we are going to get from this for loop. So as this loop is running 5 times, it will be inserting values from 0, 1, 2, 3 and 4 into the stack, and when it comes out of this loop, the stack should be full. So when I try to push another element into it, let us say the element is 5. Okay, so when I try to push 5 into this should be printing stack overflow, because the loop will already have given 4 elements as the to the push function, and those 5 elements 0, 2, 4, those 5 elements will already be in the stack, and the stack will be full. So when we try to push another element 5 outside this loop, this should definitely throw the stack overflow error. Now we'll see if this is working fine. Run. Okay, stack overflow error obviously, and since I have the print function after that, it is just printing all the values 4, 3, 2, 1 and 0. Okay, so all the functions that we have written for the stack are working perfectly fine. So in this episode we saw how to implement a stack with arrays. In the next episode we'll see how to implement the stack with linked list. Before going to that episode, I want you to do this. Go to the data structures playlist and watch the linked list videos first, because that is what is necessary for you to implement the stack using the linked list. Okay, obviously linked list. Okay, we'll be using a couple of functions from that particular data structure. So before watching the next video, here is the work. Go watch the linked list video. So I hope you understood what we have discussed in this video. If you have any further questions, please let them know in the comments. And if you like the video, please like the video. Thank you so much for watching. Talk to you in the next one.